All right, welcome, kids. It is Friday, and Fridays are awesome. Can't do it the way he did it, but let's go ahead and take care of this lesson. I have Inception in the background. No words for this lesson. If life had a soundtrack. I hope you guys are staying safe, and my thoughts are with you guys, and I hope that we can get through these next few days. I also included a tentative schedule, just outlining what we're going to do. But let's go ahead and look at the agenda that I have listed right here. Let's go ahead. I'm going to start with the puzzle question, and we have the lesson 3-4, and then all of a sudden we have the work. So nothing extremely mind-boggling for today. The tentative schedule, which I want to bring your attention to what's right there, is on Monday we're going to have a stock simulator. And the tentative schedule, on Monday we'll do a stock simulator setup where I kind of want to give you some real life application, and maybe it's not the best idea to do stocks, but it is a great way to simulate how money can grow through simple interest or compound, depending on with your data. On Tuesday, we're going to have 3-5, which is on percent increase and decrease, but we're going to spend 2 days on it because I also want to do Math IXL with that. And I will offer a Zoom meeting. It is not required. Some people can kind of it'd be nice to see everyone's faces and kind of interact and talk. But we have a feature in there that I can push out to you guys where we can join and have a video conference with whoever is there. I'll designate a time and send an invite then. On Thursday, we'll do markups and markdowns, and then we'll also have a review on that. So this brings the next question. What is e-learning, and why do it, and why not just do it later? The work and the material that you need to learn right now is something you need to have in your head or be exposed to as a 7th grader. So those that are doing the work now, later on when we come back, you won't have to redo this work. You can just go ahead and take the test and kind of move ahead. And it would seem like we will have a class that has kids that are moving at different paces. I'll have almost 2 classes in one, so to speak. Okay, and let's go ahead and get into the lesson. The first thing I want to show you is just our daily puzzle that we're going to have. Oops, don't want to have that. The daily puzzle is this, and feel free to share your answers. If I was giving rewards, it'd be the first person that has the answer would get the points. The diagrams on the right below show different views of the same cube. Which letter is on the face opposite of U? It's not a pun. It's not in terms of what U as in U-Y-O-U, but rather the letter U. So take a look at that. You can always open it on the classroom to kind of answer, and go ahead and answer it based on under the comment section. You can agree. You might have to argue or discuss what answer you think is correct. First off, let's go ahead and take a look at this short video of what compound interest is in comparison with, we should probably disable the sound. And here we go.
Is the interest an investor earns on his original investment, plus all the interest earned on the interest that has accumulated over time.
So this is different.
It is easier to think of compound interest as interest on interest. To understand compound interest, let's first look at simple interest, the interest earned on the original principal only. Suppose you deposit $10,000 into a high-interest savings account at a 5% simple interest rate for 3 years. The interest you earn each year is 5% times $10,000, which equals $500, for a total of $1,500 of interest at the end of year 3.
So this is what we learned.
$500 plus 500 plus 500.
Yesterday.
Now instead, suppose that you deposit the same $10,000 at 5% interest compounded annually. In year 1, the interest you earn is the same, $500. But in year 2, the interest you earn is 5% times 10,500, the original amount plus the interest you earned in year 1. So the second year's interest is $525. In year 3, you earn 5% interest on $11,025. $10,000 plus 500 year 1 interest plus 525 year 2 interest, or an interest payment of $551.25. In total, you earn $1,576.25 in interest over 3 years with compounding interest versus $1,500 with simple interest, a difference of $76.25. The effect of compounding becomes especially powerful over longer time periods as the amount of earned interest becomes larger and larger.
I think that's a great example or video that kind of showcases what we're talking about, but let's go ahead and dive into the lesson that kind of talks about this. Again, most people would want compound interest when you do lessons, but the thing is, if interest is working against you, like you had a car loan, you want the interest to not grow, so you would want something like simple interest. But let's go ahead, we're going to go to 3-4 if you want to follow along. At any time, you can just kind of mute me or go ahead and do it yourself. So feel free to do that. And I don't know why I can't open. Oh, wrong one. Okay, let's go to part 1. Part 1, it does the simple illustration after 1 year. We're going to go ahead and simulate that after 1 year. Oh, the first thing I kind of want to point out is that the equation for the compound interest, which you don't see yet, is actually going to be the balance. When we had IPERT, I equals to PRT, it was only the interest that we're calculating, but for this one, we're going to find the balance, which stands for the uppercase B. Okay, let's go ahead and simulate this. And then after that, we have 2 years. So you're going to see that it's simple interest calculated, and then what you're going to do is you're going to add it to it. So it's 102. Now this is where it gets a little bit more complicated, because the interest that you earn now is not 100 off $100. It's actually 100 plus the 2, because it bases off, you're earning money off this. Okay, during year 2, you're earning money off of year 1, which means technically the amount is 102. So then you realize that you earn $2.04. So that would mean this is the example of your total earnings. You can tell that based on the picture that the amount of money is growing. Let's go ahead and click on the next one right there. So after 3 years, it grows even more. And you'll notice that the interest that you calculate off of, which is right here, is from the previous year. So if you take a look at it, that's what we have right here, what I underlined. Whereas 100 plus 2 plus 204, and then all of a sudden we have more money because of that, which gives us a bigger bang for our buck. So let's go ahead and let's do a particular problem. Later on, if for those that are kind of interested, you'll notice that the compound interest equation will be actually B is equal to, I think, A sub 1, which is your initial amount or principal, and then it's 1 plus R over N to the N-th power. It's actually plus minus, depends on if it's going to grow or not. And that equation is far more complex, I believe, and we don't need to worry about that right now. But that's just where we're going to be. A lot of times math, it's teaching you where you're going to be eventually. So suppose a deposit of $200 in savings account has that earns an annual interest rate of 1% compounded annually. That means once per year. So what is the final balance of your account after 4 years, in round to near cent? Obviously, you don't want to go to a thousandth of a cent or even a tenth of a cent. All right, ready? Let's go ahead and do this. We have compound interest amount, so we're going to calculate this one at a time. Year 0 is just filling in. So I'm going to pause a second just because I want you guys to have some think time. What is the balance? Obviously, you're earning nothing because no time has passed. So what do you think the final balance should be? Well, what did you start out with? Look at the problem. Hopefully you got it. I would have called on someone that I thought wasn't paying attention, and you'll realize it is $200, okay? Then we're going to do some work on the side right here where now we have to consider the next year. So now we have 1% interest because it's notated here. And if we remember our equation, I is equal to PRT. The reason why we're doing simple interest, we're calculating compound interest in a simple way. So we're going to go year by year, whereas there's another equation that kind of helps you calculate it, the total in one step. But let's go ahead and look. We're going to do the work for this right here. So we have the interest, which we don't know yet, and the principal, which is 200, times 0.01 times 1, because it's only been 1 year. Okay? Once we calculate that, take out my trusty old calculator. Calculator's out. I'm not expecting you to do this in your head. 200 times, you could do this in your head. And hopefully you didn't write down times 1 or kept typing times 1. If you did, I'm laughing a little bit. So the interest is now 2. And all you do is you add it to the amount there. Let's go 2 years. Now, if you want to go ahead and pause this to beat me to it, if you're a little confused, stick with me here. We know that here it's going to be 202 now times 0.01 times, now it's going to be 1 year. And once again, I just want to point out that technically it is 1 year each time because the interest that you're growing upon is off of this particular amount right here. So we got 202 times 0.101, and that this time around it's going to be $2.02. You might be thinking, well, Mr. Lowe, isn't that what we just saw from before? Yeah, $204.02. Okay, this time around, third year, we have $204.02 because that's what we're earning interest off, times our 1%. I'm not even going to write the times 1 because it's not worth it. 204.02 times 0.1, and that's going to get us now an interest of, and the rounding's in your cents, so we have $2.04 here, and $2.04 plus 204.02 is now going to get us 206.06. Now, last one, 206.06 times another interest of 1. 6.06 times 0.1. Trying to give you some think time, and now we have $2.06. What do you know? There's kind of a pattern going on right here. So $2.06 plus the total from before, which you guys should know is just going to be, I'm going to give you think time. And 208, because 2 plus the dollar, and then 6 cents times 2 would be 12. So, after 4 years, that's how much we have. Let's go ahead and see if I made any mistakes. Oh, there's another video.
The principal is $202, $106, and...
Yeah, I'm right. Okay. If you like to watch the video itself, you can go ahead and stop the lesson at any time and kind of do that. Got it? Go ahead and pause the video and work on the problem, but I just want to remind you that technically you have to calculate it twice. This is a 2-step problem because you have year 1 and then year 2. Okay? Try to do that real quick. I'll help you with year 1. It's going to be I is equal to 500 times 0.03. Technically, you do have to multiply by the time, which is the year. It's 1, but we don't need to calculate it. And remember to always add it. Pause the video, try it out yourself, and I'll reveal the answer in a second. All right, hopefully you're back with me. And we have the chart right here. You can see that it was $15 in terms of the interest. So the amount is $115. Oh, $515, I'm sorry. But then you'll notice that you have to carry this over right here, where you have to now multiply it by a new amount. And then the grand total after that is this. Great. Which account balance would go faster? An account that has simple interest versus compound interest. Hopefully by now you know that compound interest goes faster because the amount that it's building interest off is increasing. It doesn't stay originally the same. One of the things that we as parents who are homeowners are very thankful for is the fact that it is a lot of times interest is built off of, actually maybe it's the other way around, but interest on mortgages are simple. It's based off the initial amount. As we pay off the house, the interest doesn't adjust accordingly, and that's when you hear parents say, "Oh, I'm going to refinance," because when you refinance, you rethink the timeline as well as the percentage that you're working off of. Okay, let's go to part 2 here. Today's lesson is going to be a little bit longer. This is that equation I talked about, and that you're going to have the balance. I would take some time to actually record this equation right here, specifically this stuff I'm highlighting. Go ahead and write it down. Take some time to write it into your notes and commit it to memory. Now, some people are probably wondering, well, Mr. Lowe, I don't understand. Why are we going to be adding 1? Well, you see, this is what happens. If you have a final balance, this is the final, so this equation gives us, we don't have to add it. It includes the original price. What number represents 100%? Well, 100% is actually equal to 1. So that is where we get the 1 from, because this total thing inside the parentheses is going to be 1 plus, and let's say the rate was 3%, it would be 0.03. So technically, eventually you're going to earn 103%, or you're going to have 103%, because you have the original amount plus a 3% increase. And the n represents how many times it occurs. It normally is t, but n is also referencing a different variable to represent this, as well as p, which is the principal, and that's the starting amount. So hopefully this makes sense. If not, rewrite that whole equation down over and over again, and then it becomes a plug and the chug lesson. Okay, so let's go ahead and look at this. I'm going to have to play the video because I need to see what's on the certificate.
And do you know what this is, little baby Eddie? This is a certificate for a $1,000 money market account that will earn 5% interest compounded annually. Isn't that a wonderful gift your lovely Aunt Edna gave you? No, don't chew it. No, don't cry. And no, don't chew. And okay, who wants to hold little baby Eddie now?
All right, we just needed the stuff on the certificate. When Ed was born, Aunt Edna opened up a money market account. A lot of times people are confused. What's the difference between when you go to what is a money market account? When you go to the bank, oftentimes they have what we call a checking, and you can always ask your parents questions about this. Then you have your savings account, you have a money market, and you have a CD. The checking, normally it's an account where you have to move money back and forth, and the ideal situation is you keep the balance at 0. You don't really earn much interest with this, but it's kind of a way of kind of securing your money moving. Savings, you can earn a little bit more interest, but money market, normally you earn even more interest than a savings. Now you might be thinking, why would anyone do savings when you can do money market? Money market normally has a minimum amount that you need to put in, and if you don't have that minimum, you can't earn as much interest. So with people that have more money, that is a better option. But let's go ahead and do this problem, shall we? Use a compound interest formula, which hopefully you have it memorized by now. It's B is equal to, oh no, I can't write, P, and then it's going to be 1 plus R to the nth power. I think that is what it was, if my memory serves me correct. So let's go plug and chug. So we need to have 3 answers, 10, 20, and 30. Now, the goal is to start saving early so that technically by the time you get older, you have a bunch of money that you didn't expect, and that's slow and steady, wins the race. So let's go ahead and plug in the first situation. So we'll say at 10 years, shall we? We have the principal. How much did Aunt Edna start with? It even lists it right there. You see the certificate? We have B is equal to 1,000. And now we have 1 plus, and what's our rate? How do we write 5%? 0.2 decimal spots, 0.5. 0.05. And as you get better at this, you can go ahead and do a shortcut. And then the number of years, we got 10. Okay, so I'm going to go ahead and type this, and the calculator might look a little messy. So some people don't know how to type in when it comes to exponents. So it's going to be 1,000, and then you're going to press the multiplication symbol. I'll kind of walk you through this. 1,000 times, and then you're going to do an open parentheses. And then you're going to type in 1. If you can just do 1 plus 0.05, it'd be a lot easier. So you can just write out the number. Close parentheses, and then you're going to hit this button that looks like a caret, or they call it a caret. I don't know why, but it's the exponent symbol. And then you're going to type in 10. And you can hit enter. Once you get that, you should get $1,628.89. And that is how much you would earn for after 10 years. Your money grew $628 just from sitting there. You didn't have to do anything as far as making more money off of it. Let's go ahead and try it for the other amounts. Same thing. It's going to be B is equal to 1,000, because the initial amount has to always be 1,000. I know before you were kind of calculating it with simple interest formula, but now we're calculating with a compound interest formula. And we're going to multiply that by, that's 1.05 to the 20th. And then next is going to be 1,000 times 1.05 to the 30th. Let's go ahead and take some time to do that. Pause the video if you guys need to do that. So I have my answer for 20 years. I have $2,653.30. In my 30 year, I have $4,321.94. Some of you guys might be thinking, oh, it's not that much money. But imagine, most people have more than 1,000. If you add, even if we add a couple zeros at the end, that's going to be $100,000. So then you would be earning that much money just from having money sit there without putting more money into it. Most of the time, people put more money each time around into it. But that's a lot of money, and that's smart investing for the future. Okay, this time around, I'm going to have you do this problem, pause it, and then see if you can solve this, and then I'll hit the solution in a second. Welcome back. The answer is going to be B, which is 1,600. The solution can be shown with this equation right here. Hopefully you put in the right numbers right there. And I'm going to go ahead and you can pause it if you need to to read it. Hopefully you're actually writing, at the very least, guys, at the very, very least, you should at least have this stuff written down. The work leading up to that, that's up to you guys as far as how much work you want to show, but it should get you the answer right here. If you didn't get the answer, that means your method did not work. So consider writing more things down. All right, let's go to the key concept right here. I have my son Isaac right next to me. He is also doing the same lessons. He's doing, well, I'm doing this video ahead of time, so he's doing simple interest.
I accidentally pressed this button and refreshed my page, and I started over.
Oh no. Skip to the problem that you're on. I'm okay with that. All right, this kind of does an overview as far as what are each parts right here. I'll kind of unveil all of it, but that's kind of what we were talking about before. Now, what could be interesting to you guys is if R now has this issue right here, and if you saw me write R over N, that is kind of what I'm talking about, whereas N references how many times in a year it occurs. I don't think that you will see that in future problems in higher level math where they say it's compounded quarterly or compounded monthly, to which the n would be quarterly would be 4, and if it's monthly it'd be 12. I don't believe there are questions like that on this homework if my memory serves me correct, but we'll adjust accordingly if it does. Part 3,